So yeah, main topic today will be the thermal wizard. We are experiencing frequently questions from our customers regarding thermal management problems, and we have developed a tool for our customers that will help them and support them regarding their thermal management questions. It's a web-based application, so it means it's available on all platforms, regardless if it's PC, Mac, iPhone, or Android. So it will run in every web browser. It basically is an assistant for thermal modeling that will help you to calculate your cooling requirements if you have known parameters, but it will also help you by predefined examples as a starting point if you are not sure about your parameters for your application yet. So to cut a long story short, I will immediately, and I have to interrupt the PowerPoint presentation here, I will jump to my web browser to show you what the thermal wizard is. So if you open our website, and I hope you can still see my browser okay, you will find the thermal wizard right in the middle of the navigation bar of the Laird Thermal Systems website. And so I'm going to choose the thermal wizard here. And as you can see, it's a tool that does have predefined examples, and we talk about this in a minute. But it basically covers all 4 sections of our product portfolio: the thermoelectric coolers, the assemblies, the liquid cooling systems, and also if we are talking about custom cooling solutions. So basically, I would just like to give you a start. If you have a known parameter, let's say you already know your cooling requirement, and your cooling requirement is 150 watts. We leave out the delta T out of the equation for the moment, because let's say you just know I need 150 watts of cooling, because that's typically something a customer would approach you with. So I'm going to enter the 150 watts of cooling power here, and I simply click the search button. So after a few moments, the thermal wizard will come up with a list of products that will match your cooling requirements of 150 watts. As I've said, we have different product ranges, the thermoelectric coolers and assemblies. We usually like to recommend them for applications up to 400 watts. We have some assemblies that are slightly more powerful, but that's a general rule of thumb that we like to give. So in any case, we entered our cooling requirement of 150 watts, and the thermal wizard will present us with a list of matching products. I'll leave the Peltier modules out for the moment, because let's say we want an air-to-air cooling application. So I'm going to select the first product here in the description. And whenever you take a look at one of our products, you will be presented with an interactive data sheet. It's basically available for all thermoelectric coolers and all thermoelectric assemblies. And there's also an interactive data sheet available for the liquid cooling solutions. So generally speaking, we know that this product would match our cooling requirement of 150 watts. What you usually then would do, you would take a look at the interactive data sheet and check the physical dimensions of this unit, because sometimes you have constraints regarding the space. So you can check the dimensions of this unit here. Probably the more interesting part then really is the interactive data sheet. So as you can see here, you have the opportunity to select from different charts. As a standard or default chart, you will be presented with the QC, the cooling power chart. And as you can see here, we are getting something like 160 watts. And this more or less matches the product description. It's an air-to-air cooler, 170, 24 volts. So we are getting very close to that. So in the chart or as a standard default, we are usually using 35 degrees for T ambient. But let's say your application is running in 20 degrees. So I would use 20 for ambient and control temperature because the cooling power in this case is defined at delta T of 0. You click the update button to check if this unit would still be able to provide 150 watts of cooling power, which was our initial request at 20 degrees ambient. And with 20 degrees, we are getting 160.5 watts of cooling power. So the unit would still fit our requirements. You then also can check the nominal voltage here is 24 volts. You have the slider on the left side, which will allow you to see if you change the voltage, if this will impact the cooling power. So I'm going to slide this down. And as you can see, the operating point is moving here. So in this case, we are slightly below 150 watts. So we are getting 146 watts. So I'm moving the slider back up, let's say to 20.5 volts. And we are close to 150 watts. I'm moving it back a little bit higher to 21 volts. And I'm back to 150. So what does it mean? It basically means you can operate this unit between 21 and 24 volts to achieve your required cooling power of 150 watts. This might be important if you only have a certain voltage available, or if you are looking for a certain efficiency in your product design. All the interactive data sheets offer different charts. We are looking at the cooling power right now, but you are also having a COP chart with the coefficient of performance, the total heat dissipation on the hot side, and you can also look at the current or at the delta T charts that are available for this product. You, of course, can also then run different simulations. If you, for example, want to know how much cooling power do I have if I change my control temperature, if I want to cool it down to 10 degrees, you then can hit the update button and the chart will refresh in a moment, and you can see the operating point is changing. So we get 105 watts in this case at a delta T of 10 degrees. The beauty here is, and I like to use it a lot, for example, you have a customer who is giving you exactly these requirements. I want to cool down my application to 10 degrees with 20 degrees ambient. You then can have your customized data sheet. So you can either select between the standard data sheet, or you can save your changes based on the input data that you have provided to the Thermal Wizard at this stage. So I'm going to do it right now here. It will usually take a few moments. And here you can see we have a data sheet that's based on the exact figures that you have entered in the thermal wizard. So you're not limited to a default data sheet, but you can have a customized data sheet based on your application data. And this is available. You can already see it here. It already has been downloaded as a PDF. And there's also a PDF export function here. I like to use this a lot to give this out to a customer who has a special requirement, and you can make as many modifications as you like. So it's not limited to one modification. You can make more modifications. Okay, so I'm just jumping back here. Basically, you can use this with any kind of voltage and with any kind of cooling requirement. Let's say, sorry, not voltage, watts. So let's say you have a cooling requirement from your customer with 30 watts at a delta T of 20 degrees. You hit the search button, and again, you will be presented with a list of matching products. What's important to know, if you take a look here at the cooling power, it's always matching the delta T that you have entered above here. So it always takes into consideration your requirements. However, there are cases where you don't have a clear idea what kind of cooling requirement you need. And maybe you don't know your delta T either. So that's where we are helping with a couple of predefined samples. And if you select the thermal wizard, they will be presented right here on top. We have 5 different predefined sections. So we have a section for the device cooling calculator, and we take a closer look at this in a minute. We have it for enclosure cooling, we have it for air cooling, for liquid cooling, and also for PCR cooling. The PCR cooling is very specialized application, and I'm not going to dive into details today. Most of you are probably familiar with the expression PCR due to the COVID-19 situation, because a lot of PCR testing is done for COVID-19. However, I just give you a short glimpse because it's a highly specialized calculator. For those of you who are dealing with PCR designs, we have predefined examples for the thermal wizard that will deal with the design of PCR products. Because it's really a very sophisticated application, I'm not going to dive into that today, but we can cover this, and this will also be shown on one of my later slides. That, of course, we are also available for one-on-one presentation. Okay, so let's take a look at the predefined sample section. So I'm going to choose the device cooling calculator, and I have already prepared this. So if you select any of the predefined samples or sections, and in this case, device cooling, you will be presented a couple of predefined samples that should help you as a starting point. For the device cooling, we have a laser diode, a medical laser, CPU, or CMOS sensor, DLP chip, or pump laser. And for my presentation, I'm going to pre-select the medical laser today. So if you select one of the predefined samples, you will see that the thermal wizard will fill in the parameters that are required for the thermal calculations. In this case, the laser, the medical laser, has an active load of 19.2 watts. Let's take a slightly smaller laser. So the laser of your customer or your own laser application is 6 watts. And as you can see, immediately the calculation screen will change. We are also going to change the dimensions of our heatsink. So let's say we are going to use it 20 by 20 by 10 millimeters. And again, you will have an immediate update here on your screen. We are not going to use any insulation. The predefined settings for the thermal or for the temperature are 10 degrees and 35 degrees ambient. So what we call control or internal temperature is always the temperature that you are looking to cool down your application. So you can change this according to your requirements for the device calculation, cooling calculation. We can go as low as -40 degrees, but I'll leave it in this example by 10 degrees. We don't need to cover the insulation because we are just going to use an aluminum heatsink here in our application. However, you could always add insulation if you want to, and I will show you in a later example why the insulation does have an impact on your calculations. So we have entered, I'm changing the spec to 10. We have entered our parameters and we are going to hit the search button. The Thermal Wizard will show us that it requires 6.87 watts of cooling power for our application, and the active power dissipation in this application is 6 watts. This is also presented here on the right side. So on the right side, you always have the parameters of your applications. So we could already look down and we are presented with a couple of thermal-electric modules. We are also presented with thermal-electric assemblies that would match the requirements, just like in the previous example that I gave you. Cooling power is always referred or is always listed compared to the delta T that we have chosen. In this case, it's 25 degrees, and this matches the difference between the ambient and our control temperature. So there's one interesting slider here on the right side. It's the minutes to cool, and I'm going to show you what does it mean. So you can move the slider. Let's say you want a faster cooling. In this example, we have 15 minutes and it would require close to 7 watts of cooling power to match our application requirements. So if you move the slider, you see that nothing changes here. They are still the same. So that means that the steady state still dictates our cooling application. Once we are approaching, and now you can see that the numbers here are changing to more than 7. Once the transient will dominate, this will also have an impact on the QC specifications. So let's say we want our application to be cooled down in 2 minutes. So we end up with 8 watts of required cooling power. We hit the search button again. And just in our previous case, we will be presented with a couple of possible options. So let's say we are looking for a small solution and we have only limited space. On the right side of the suggested modules, you will also see an overview of the dimensions. And let's say we only have between 15 or 20 millimeters space available. So we would select one of the two top options. And just like in the previous example, you can then jump into the interactive data sheet, and it looks exactly like the one we looked at before. Again, you can make possible adjustments in addition to the thermoelectric assemblies for the modules. We also have the capability to enter a hot side and cold side thermal resistance because this might impact your cooling power. Let's say you are adding a heat sink on the hot side with a thermal resistance of 0.2. If you then update your chart, you will see that the cooling power is slightly lower than with the thermal resistance of 0. Again, you can just use the standard data sheet, or you can add further modifications, like you would like to know how much cooling power do I have if I change it to 5 degrees. It's the same principle, and also the same principle here. Let's say you would like to know how much can I lower the voltage. We don't have many or much headroom here, because if I'm going towards the 4 volts, I'm already below 8 watts, and I think we needed around 8 watts of cooling power for our application. The same principle applies for all the predefined examples, and you can use whatever example matches your application closest. Please keep in mind that the numbers you get here, these are calculated numbers. So I always like to tell our customers to add some safety margins because there always will be some losses in your application. So maybe you like to add 10-15% as a safety margin. It really depends on the application. But I just want to let you know that the numbers here, these are calculated numbers. So I always like to add some safety margins because then you have some headroom for your application. Okay, let's jump into another example. And this is, so the device cooling, this is one of the examples I'm using really a lot, because a lot of customers are asking for such kind of applications. The other application that's really very popular is the enclosure cooling. Again, we have a couple of predefined examples, like a battery box, electronics cabinet, or sample cooler. For our short demo here, I am going to use the electronics cabinet. So by selecting it, I will then have predefined dimensions. You can change them to whatever you like. So if your customer has dimensions like 80 by 80 by 40, you just would add these dimensions. What's very interesting in this case is you see a couple of icons here, like the heat transfer, the insulation, and the solar gain. There's one possibility here for outdoor applications. You can also add the solar heat gain, and you can also select the finish, so white or gray, black, or reflective metal. But let's say we have an indoor application, so I'm selecting this, and I de-click the solar gain icon for my application here, because there's no sunshine in an indoor application. And let's say the front door, typical box network cabinet, there is a glass door, so there's no insulation here in the front. So I deselected here, and so let's say we are now looking at, in our example, at a cooling load of 240 watts, and this is also coming from that in the example. There's a active heat load of 80 watts. Let's say you have some kind of electronics inside your box. You can then enter the active load of that electronics. I'm going to change it here to 100 watts. And let's say we have a foam insulation of 15 millimeters in our application. So once you hit the search button, you will also see the updated total cooling load. And just to give you some idea how important insulation is, if I change the insulation to 25 millimeters and I hit search again, I can see that I will have a lower cooling requirement to reach my target temperature of 25 degrees in 35 degrees ambient. For the insulation, you can use different type of insulation. So we have a couple of insulations predefined, like glass wool, rubber, plexiglass, glass, but you can also, if you have a special insulation, you can also enter the thermal conductivity. So that's fully editable. So you can enter your own thermal conductivity. So you're not limited to the insulation types that are available in the predefined samples. Yeah, let's take a look at the suggested products. I'm going to discard the thermoelectric modules here because for my cabinet, I want an air-to-air cooling, and you will be presented with a couple of thermoelectric assemblies, air-to-air assemblies, or in the last option is liquid-to-air that will match our cooling requirements. In this case, we needed 234 watts, and the air-to-air assemblies here, these are the most powerful assemblies I was talking at the beginning of our presentation, where they have up to 480 watts cooling power. So you would then jump again into the interactive data sheet. Of course, same procedure here. You would match if the physical requirements or the dimensions would match your box or the space available for cooling. And then you can make the same modifications that I've shown you on the previous examples. So, yeah, that's basically, or these are the main functions of the predefined samples. We are offering the very same for air cooling, so where you can use all kind of examples for like a Peltier condenser or medical oxygen. And the principle always is the same. Here in the air cooling, it's a bit more limited because you have less parameters due to the nature of the application. But they work just the same, and the same also applies for the liquid cooling calculator. Let's say you have a flow rate, or you need a flow rate of 5 liters per minute, and you can also select from water or a mixture of water and glycol, because in many applications you require a water glycol mix for your coolant. And you can also add your own fluid if you have a special fluid that you are going to use for it, because density and specific heat parameters are fully changeable by the customer. And we have the same here. So if I hit the search button again, or in this case, this was a bad example, or we don't have anything that will match 5 liters per minute at these conditions, but let's say we only need a flow rate of 2 liters, then we can come up with a couple of options that would meet our requirements. Okay. Yeah, as you can see, the usage is pretty easy. You don't need to have your cooling requirements or the delta T available. By using the predefined examples, you will be able to narrow down your product selection, and you always can change the parameters that we have seen here. So everything that you see on the screen is fully customizable. So there are no limitation, and you can use it as many times as you want. You can make as many changes. Also, if you go into a specific product, you can make as many changes in the interactive datasheet as you want, and you can save as many customized data sheets as you wish. For example, you want to show your customer a data sheet with a delta T of 10, and you want to show the same product with a delta T of 20. You can have savings or save them to different data sheets. Okay, I'm going back to my presentation now. So again, we have questions and answer session at the end. There's also one thing I would like to encourage you to do. A lot of the things that we have talked about right now, so delta T, enclosure cooling, air to air. We have two two handbooks. One is the thermal electric handbooks for the thermal electric modules, and we have the thermal electric cooler assembly handbooks, and they are available for free on our website, so you can download them for free. And I like to read in them myself because they are great collections of basic principle, and sometimes it's really good to have a reminder what could be a good idea when you are approaching thermal management design. So yeah, I would like to encourage you. These two handbooks are free on our website. There's another tool on our website I would like to show to you. That's called the parametric search. It's available for the thermal electric modules, and also since a couple of months also for the thermal electric assemblies. This year, more than ever, due to the unfortunate situation, I'm having a lot of customers coming to me who are saying, okay, I have a thermal electric module from brand ABC. Dimensions are 40 by 40 millimeters and 50 watts of cooling power. What do you have? So I'm going to show you this on our website. So if you take a look at our thermal electric cooler sections, there's a large variety of series. And if you jump into a particular series, let's take the UTX series here, you will find many modules. Frankly speaking, there are so many, it's hard to remember the specifications of every series and every module. And that's where the parametric search comes in handy. It's either available in the quick link section of our starting or landing page, or it's also available in the thermal electric coolers product page. So what does the thermal electric coolers parametric search do for you? As I've mentioned, I have many cases where a customer comes to us saying, okay, I need a module 40 by 40 with 50 watts of maximum cooling power. Or you get a data sheet from a competitor where you can see all the specifications. So what you can do here now, you can use the parametric search to find the right product from our portfolio for you. Let's say it's a high temperature application. So you can pre-select, or first of all, you would select a single stage or multi-stage module. So single stage is pre-selected, but then it's high temperature application. So you select high temperature to narrow down the selection. As you can see, there's already a live update down here with all the modules that would match your requirements. I'm selecting the ETX series here, and the customer said, okay, I need a module 40 by 40. So you can either use the exact dimensions like here, or you could use a range like, okay, I give him some headroom, so I'm using or searching for everything between 40 and 50 millimeters. But let's narrow it down to 40 by 40 in this case. Okay, so you now have an overview of all modules from the high temperature series that would match these requirements. But let's say I have certain QC max specification. So I need 140. I'm going to narrow this down. Let's say I need at least 55 watts of cooling power. I'll make this a bit higher. Let's say 75 watts. So as you can see now, the selection has been narrowed down to these modules. So this means all these modules would match the customer specifications or requirements. Let's say he says, okay, I'm limited to IMAX of 10 amps. I don't have, or 9 amps. I only have 9 amps. So you can then narrow this down to 9 or 8 amps, and you see that the selection gets smaller and smaller. So the more parameters you are using here, the better is the final selection. You've already seen what's happening now, so you can click in the part number in the description and save your data sheet. It does have a couple of more options, the parametric search. So, for example, let's go back to all series. Let's say you want a module between 40 and 50 millimeters in length and also in width. And let's say you need at least 35 watts cooling power, but you need a sealed temp. So you can also use the sealant as a criteria for your search. And let's say you need a gold-plated. Okay, in this case, there's. Hello?
Go on, Sönke.
Yeah?
You have 2 minutes left.
Yeah, okay. Yeah, I'm almost finished. Okay. So, I'm just showing this very quickly. This parametric search is also available for the assemblies. So we have the same here. So you could pre-select from air to air, direct to air, liquid to air, but the principles are the same. Okay. So I'm jumping back into my presentation. Yeah, as I said, it's a good tool finding an alternative for existing TEM, and you can also create a custom data sheet for your customers. As I've said at the beginning, because of course we only had limited time today to show a lot of stuff, and I hope it wasn't too confusing and too much. If you have the need for an individual session, please reach out to Telerix. They will able to show you the Thermal Wizard, and I'm more than happy to join you for that session. Yeah, questions and answers. I'm going to turn back my camera on if you like.
Okay, thanks, Sönke. I will check the audience and provide them the microphone if there are some questions. In the meantime, maybe I can ask Thomas to prepare for the next presentation on the microphone. Christian, there's one question coming up, Sönke.
Thank you. Hello, Sönke.
Hi.
I have a question concerning the wizard. Can you use it also when you have heating applications?
That's I expected that question. It's not available today. If it's part of the PCR calculator, because the PCR calculator already has heating incorporated. I expect this feature to be fully available next year, but I don't have an exact time frame for that now. There are some, I say, tricks or workarounds how we can utilize it today, but it's not an official feature yet. But thank you for asking this, and I will forward this to my colleagues from the marketing department because I have been asking for this feature for quite a while now. But it will be the next feature available for the Thermal Wizard.
Okay,
Yeah. So
thank you.
it's coming.
Thank you very much.
You're welcome.
Okay. See if there are other questions. Norbert?
Hi. My question is in the past, Wizard, you did have also the option that you can select more parallel or serial tags. Is that also available in this one?
It's not available in this one, but this is also one of the features that will be coming, so that you can simulate parallel or serial connections and also comparing temps with each other. So these are, I'm really glad that you are asking all these questions because I feel these are the most important additions that, yeah, I'm looking for the Thermal Wizard, and they are definitely all in the pipeline. And yeah, so it will be coming next year.
Is the old wizard still, or there was a program you can download and use on
Yeah.
PC? Is that still up to date, or that's now outdated and this is the replacement of that?
And yeah, it's the replacement, and actually the developer of the, I think you are referring to the AdStack software.
I liked it very much.
Yeah, yeah, it's a good software. And the developer of the Thermal Wizard, that's also the developer of the AdStack software.
Okay,
so that's why he has a great knowledge about it. In fact, I just talked to him yesterday, and but the AdStack software is no longer up to date, and so the Thermal Wizard will be the tool for, or is the current tool. And also it will have some features in the future that are no longer included in the AdStack software.
Okay. And another question, if I can, may I ask, the background of the software, is that all based on experimental testing done, or is it just the datasheet values what you put in with some?
Yeah, these are calculated numbers, just like in the AdStack software.
Yep.
So some of the formulas obviously well known for everyone, but in some cases, like let's say in the enclosure cooling or in some of these special cases, there's a bit more behind the engine that's not really available, but the numbers are calculated numbers, and maybe in the future edition, but I don't think this is an A priority. So heating, serial, parallel, all that you have mentioned, this is a priority for me. Maybe adding system losses or adding other parameters is it's B priority.
Yeah. Okay. Thank you. I find it very handy. I use it quite a bit.
I'm glad to hear that.
Okay, good. Thank you.
I'm glad to hear that. And just one more addition. I know that you have been talking about OTS this morning. So the thermal wizard is not a full thermal simulation. So if you need a full thermal simulation, then Telerex and OTS surely can provide the services for that. But it's a great starting point. And as you said, I'm using it every day for my work. Yeah. Okay.
Okay, that was a good one too. Great, thanks for that. Are there any other questions? Maybe I'm not too close to the other mic.
Okay.
Okay. No. Thanks a lot, Sönke, for your contribution.
Thank you.
Normally, would have given you a nice present physically, but unfortunately, it will oblige me to drink it myself this weekend. Or maybe I can find a transport company which will bring you to your doorstep. But you will get this, of course, this gift from us as a thanks for your presentation.
Thank you very much, and thank you all for your attention. Thank you for allowing me to be with you today, and have a good afternoon, and goodbye. Okay, thank you. Bye-bye.
Bye, Sönke.